Alright, so scalar and vector projections. Let's actually talk about what's going on. Whenever you have a scalar or vector projection of a vector A onto a B, if say this is our vector A, and this is our vector B, and we're doing the scalar and vector projection onto this, what you're going to do is you actually drop a 90-degree angle from the top of A down to B, and the scalar projection actually gives you this length, what it tells you. The vector projection will give you this vector. And after we actually work out this problem right here, I'll explain a real good application about it. So let's first talk about the scalar projection. Okay? Scalar projection, you're going to see it as this. You're going to see a comp. And now here's the important part. This onto. When you see onto, I want you to think on top. Okay? So, when we have the vector A is on top of B, I'm literally going to put A on top since it's onto B. Every scalar projection, every single one, always starts off with A dot B. No matter which one's on top of which, you always do the dot product. Divided by, now here's the important thing, whatever is on bottom, you're going to swing this across and do the magnitude of B. Now notice scalar means number, so your final answer should be a number. If you output a vector, if it asks for the scalar projection and you get a vector, chances are you did something wrong. So notice the dot product is a number, magnitude of B is a number, so we're good to go. So A dot B, A dotted with B, is equal to, now notice this I plus J. That's just another way to write it. Me personally, I like brackets, and so I'm going to do 2, 1, dotted with 3, 4. To do the dot product, you multiply your x terms, so 2 times 3, plus you multiply the y terms, 1 times 4, so 6 plus 4 is 10. So A dot B is 10. The magnitude of B, or the length of a vector, is going to be the square root of each of your components squared. So if B is 3, 4, the magnitude of B is the square root of 3 squared plus 4 squared, square root of 9 plus 16, square root of 25, which is 5. So therefore our scalar projection of A onto B is A dot B, which is 10, divided by the magnitude of B, which is 5, which is equal to 2. Alright, let's talk about the vector projection. The vector projection, okay, note sometimes you're going to see it as proj. And what I think proj, projection, the bigger one, whatever you want to remember it. Okay, we're still going to have A on top of B. The vector projection starts off, you always start off with the scalar projection. So the scalar projection is the first thing you're going to do. It's going to be A dot B over the magnitude of B. Now here's what we're going to do. Let's come back to our picture over here. The scalar projection gave me this length. So if I want the vector, this vector right here, I want to multiply this length by the unit vector of B. Okay, and the unit vector of B, whatever you swung across, you're going to be using that everywhere. The unit vector of B, y'all should know, is B over the magnitude of B. Okay? What this is equal to. We already found the scalar projection in part A. And how on your test, you're going to see part A, find scalar, part B, find vector. So you don't need to do it all over again. We already know the scalar projection is 2. The vector B is 3, 4. And we already found out that the magnitude of B is 5. So this is equal to 2/5 times the vector 3, 4, which when you multiply 2/5 into their final answer is going to be the vector 6 over 5 and 8 over 5. And notice the vector projection gave me a vector, the scalar projection gave me a scalar. Now, where you're going to use this is for problems that say find the distance between a point and a line. Let's say we have the line y equals, I don't know, let's do 3x plus 1. here's a line y equals 3x plus 1, and here's a point, we'll call this guy, I don't know, what do y'all think? We'll go to 16. Okay, and we want to find this distance, okay? What we can do is I'm going to pick a random point, and normally I like to pick the point along the y-axis, okay? And what we're going to do is I can find this vector. Remember, all this vectors, I'll call this vector A, okay? All a vector is your change in x over change in y. Well, what is that? That's just the slope. The slope of this line is 3, so I'm going to call this vector A 1, 3. Okay, now what I can do is from that same point, I'm going to make a vector B to this dot. And so here if I cross the y-axis at 1, vector B, my change in x, I'm going 6 across, and I'm going up 1, so the vector B would be 6, 1. Now what's going to happen, let's take a look at this. I can find the scalar projection if I do the scalar projection of B onto A, which is 90-degree drop, it gives me this distance. So now I have that distance. The magnitude of B gives me the length of vector B, and now what I have, since I have a right triangle, you can just use Pythagorean theorem to find this length. And that's how we're going to use scalar and vector projections in order to figure out the length from a point to a line.